These are the video notes for operations on fractions. The first part is kind of an introduction to fractions, the basics, and then we'll get into all the operations on fractions. So, when we first learn fractions, we learn them in the form of little segments and part of a whole. So a fraction is a part of a whole. So if I were to shade one piece of this, that would represent one piece out of 4 total pieces. Same idea here. If I were to shade, let's say 1, 2, 3 pieces of this one, that would be 3 out of 4, 5, 6, 7, 8 total pieces. So it's a part out of the whole, or the total. Part out of a whole. So the first few exercises are just refreshing our memory on what it looks like visually to have a fraction. There's also something called fraction bars. And this is the same idea. So if I were to shade 2 pieces of this, it would be 2 out of 1, 2, 3, 4, 5. Or I might shade, let's do 1, 2, 3, let's do 5 pieces out of 1, 2, 3, 4, 5, 6, 7. So that would be 5 out of 7. So that's where fractions come from. They're parts of a whole. And we'll learn how these translate to decimals later. And so a fraction always has a top and a bottom. The top, if you remember, is called the numerator. And the bottom is called the denominator. And I always remember that the denominator's on the bottom. I think D for dungeon, and dungeons are on the bottom. So that's how I remember denominator on the bottom and numerator on the top. So you'll see those words. I generally just call it top and bottom. That's just easier for me when I'm teaching. So there are 2 types of fractions. One is called a proper fraction, and that is when the numerator is less than the denominator. And so that's what I consider kind of a normal fraction. Top is smaller than the bottom. Then we have what's called an improper fraction, or not proper fraction, and that is when the numerator is greater than the denominator. And that looks weird. 7 out of 3. 7 parts out of 3 wholes, which just doesn't sound right at all. We're going to learn a little bit later how to fix improper fractions and turn them into what are called mixed numbers, but we'll get to that in a little bit. From there, we're going to talk about how we plot fractions on the number line. This can be a little confusing. So if we have a plain old number line, we're going to put 0 in the middle. We're going to put +1 way over on the right and -1 way over on the left. And between those, we'll divide it out to be able to plot these fractions. So we want to plot 2 out of 5, 4 out of 5, and -3 out of 4. So these first 2 fractions are out of 5 parts. So I need to section this off. There's 1 part, 2 parts, 3 parts, 4 parts, and 5 parts. So I've sectioned this off into 1, 2, 3, 4, 5 parts. And so 2 out of 5 would go from 0, 1, so this is 1 out of 5, 2, this would be 2 out of 5. The next mark would be 3 out of 5, 4 out of 5, and +1 is 5 out of 5. So if I'm going to mark where 2 out of 5 is, I'll put a big dot at 2 out of 5. And then if I'm going to mark where 4 out of 5 is, put a big dot where the mark is for 4 out of 5. So I believe on the homework it's already marked off for you, and all you have to do is drag the mouse to the correct tally mark and just place your point. If you have to divide it out yourself, you just divide it into the total number of sections that make up the denominator. So for -3 out of 4, we're going to be over here on the negative side. This time we're only going to divide it into 4 parts. So there's 1 part, 2 parts, 3 parts, and 4 parts. So this is negative 1 out of 4 because it goes backwards, negative 2 out of 4, negative 3 out of 4, and negative 1 is negative 4 out of 4. So each tally mark is a part of the fraction. So if I'm going to plot negative 3 out of 4, I'll put a dot at the 3rd tally mark, the 3rd mark, and that is negative 3 out of 4. So you're just going to drag your mouse on your homework and click at the proper mark. We also have absolute value for fractions. Works the same as integers. So remember those vertical bars mean absolute value. So if I want the absolute value of negative 3 out of 5, it's just 3 out of 5. No more bars, no more negative. Same thing for the absolute value of 1/3 is just 1/3, no more bars, just 1/3. So that's the same, not too bad. Then the end of this section gets into what are called equivalent fractions, and this is a big part of fractions. I will warn you, your book talks about something called prime factorization, which is just a mess. It's way overdoing equivalent fractions, and I think it's just overkill is what I call it. It makes it way too complicated, and I think we can handle equivalent fractions without prime factorization. So if you're in your homework and you click on View an Example, they're going to pull up a technique called prime factorization, and I just don't think that's necessary. I think you can work these without working out all the details in prime factorization. So just ignore it. But let's think about equivalent fractions. We have 1/2. And we need to think of another fraction that is the same, that is equivalent. So the first one we usually think of is 2 out of 4. 1 part out of 2 is the same as 2 parts out of 4. And we can keep going. It's the same as 3 parts out of 6, 4 parts out of 8, 5 parts out of 10, and we can keep going and going and going. We can have 50 parts out of 100. All we're doing is doubling the top number. So I can make up whatever top number I want, and as long as I double it, I'll make an equivalent fraction. So I think we're comfortable with that, and you can make up whatever equivalent fraction you can, and this can continue forever and ever and ever. Same idea with 3 out of 4. I can make an infinite number of equivalent fractions. Usually the first thing we like to do is double the top and double the bottom. We can triple the top and triple the bottom. So this would be multiplying by 3, multiplying by 3. We can multiply by 4, multiply by 4, and we can just keep on going. Multiply the top by 5 from the original, multiply the bottom by 5, multiply the top by 6, multiply the bottom by 6. And this can again continue forever, just making equivalent fractions. And so any fraction I start with, I can come up with an infinite list of equivalent fractions, and we'll practice some of that in class when we meet. So that's it for the intro. I think it's all information you're at least vaguely familiar with. The first part of your homework will have you working with fraction parts, and then identifying proper and improper fractions. You'll plot some fractions on the number line. There might be a couple of absolute value questions thrown in there, and then creating equivalent fractions. So hopefully all fairly straightforward. The next section is an extension of equivalent fractions, and it's again one of the big skills we have when dealing with fractions, and that is reducing fractions. So we reduce fractions by dividing. We reduce fractions by dividing the top and the bottom by the same value. Keyword is the same value. I can't divide the top by 2 and the bottom by 3. That will not make an equivalent fraction. So we reduce fractions by dividing the top and the bottom by the same value. Very important for it to be the same value. So if I have 12 over 20, I need to think of a number that divides into 12 and divides into 20. The first thing I do when I'm trying to think of these is if these are both even numbers, 12 is an even number, 20 is an even number, I know that they can both divide by 2. And that's going to give me 6 over 10. And then I can keep going and say, well, 6 is an even number and 10 is an even number, so I can divide by 2 again. Top and bottom. And that gives me 3 over 5. Well, then I think, is there something I can divide 3 and 5 by? No, only 1. If you're going to divide by 1, it won't really change anything. So this is a reduced version of this same fraction. Some of you might know your multiples a little bit better. So if we start with 12 over 20, you might say, well, I know they can both divide by 4. And so I know that 12 divided by 4 and 20 divided by 4 will give me 3 out of 5. So you divide by what's comfortable for you. Some students like to start small and divide by 2 or 3 or 5, starting very small. Some students can kind of jump to the bigger numbers and divide by a bigger value they both divide by, and they get to their answer a little bit faster. But I don't want you to feel pressured to jump to the big numbers. If you're more comfortable just dividing by 2s or 3s or 5s, then please do that so that you're not feeling pressured to make those big jumps. But either way, you get to the same answer, and I don't care which way you work it out. So we always reduce fractions to what is called, what are called lowest terms. So you'll see that phrase in your homework, lowest terms. This is also called simplifying. So you'll see the word simplifying or simplified or ask you to simplify, or it might say reduce the fraction to lowest terms. Lowest terms is when there's nothing else you can divide by other than 1, and it's in its lowest terms with the smallest possible numbers. So we're just going to practice that a few times. Some students are a little faster with this, some of us are a little slower at this. I'm going to start with the small numbers, and then if you're more comfortable jumping to a bigger number, that's perfectly fine. So I'm going to start a little bit small here. 15 and 45. Well, they both end in 5, so they can both divide by 5. And that's going to give me 3 over 9. Once I have 3 and 9, I know that they can both divide by 3, and that's going to give me 1 over 3. Some of you might have known that 15 divides into 45, so you might have divided them both by 45 and jumped straight to 1/3, which is totally fine. It's just based on your comfort level with your division and your multiplication skills. 21 over 36. It's a little bit trickier. They're not both even numbers. So if they don't divide by 2, they can each divide by 3. So if 2 doesn't work, try 3. 21 divided by 3 I know is 7. 36 divided by 3 is 12. 7 is what we call a prime number, so there's nothing else it will divide by other than 1. And I know that I'm done. Negative 2 over 8. Don't let the negative scare you. If it starts negative, it will end negative, so just immediately put that mark. 2 and 8 can both divide by 2. And that gives me 1 over 4. So it's negative 1 over 4. Put your negative out in front of your fraction, and then put your fraction. Remember, you can pause the video at any time, and you can just work some of them out. So if you'd like to pause and try these 3 problems, and then you can play the video and see how you did. You can do that at any time. You can rewind, you can watch again, whatever you want to do. So if you want to pause and try, that's fine too. This next one, 3 over 8. 3 is a prime number, so there's nothing we can do. So the answer is just 3 over 8. So if you get to one and you have thought of every possible number you could and none of them work, it probably is already in lowest terms. So 3 over 8 would be your answer. The next one we have negative 3 over 15. So if it starts negative, we'll still have a negative. 3 and 15 can both divide by 3, and that's going to give me 1 over 5. So negative first, and then 1 over 5. 5 over 10, those can both divide by 5. And we'll get 1 over 2. Notice I'm boxing my answers. I think we talked about that in the last set of videos. As you work through problems, when you get down to your final answer, it's a good habit to put a box around it so that you know that you're done and you know that that's your final answer. Alright, here's the next set. You can pause and try, or you can just watch me. Negative 24 over 30. So I'm going to keep that negative. 24 and 30 are both even, so I can divide them both by 2. That's going to give me 12 over 15. I know that both of those can divide by 3, and that's going to give me, again, negative 4 over 5. Some of you might have divided them both by 6 to begin with, and that's okay. So negative 4 over 5. 9 over 12, they can both divide by 3, and that gives me 3 over 4, and I'm done. 15 and 40, this one ends in 5 and this one ends in 0, so I know they can both divide by 5, and that gives me 3 over 8, and I'm done. So you just use whatever numbers come to mind. If you're not sure, try 2. If 2 is not going to work, try 3. If 3 is not going to work, try 5. So 2, 3, and 5 are the main numbers to start with. After 5, you can try 7. That's kind of rare, but they might both divide by 7. But one of those numbers, 2, 3, 5, or 7, should work. After that, the next number is 11, which again is very rare. Alright, the next part of this is the same idea. We're going to fill in the blank, fill in the empty space with the number that makes this true. And the way to do this is to think, how do I get from 20 to 4 with multiplication or division? And you should think divide by 5. So we're going to do the same thing to 15. We're going to divide by 5. 15 divided by 5 gives me 3. So you use multiplication or division. How do I get from the first fraction to the second? So the answer that you would type in is 3 to make 3 over 4. Same thing here. We have negative 1/2 equals, and there should be a negative on there. So from 2 to 16, for multiplication or division, that would be multiplying by 8. So I'm going to do the same thing here, multiply by 8, and that gives me 8. So that should be negative 8 over 16 as the answer. So I think that's pretty straightforward. Just remember you use multiplication or division to go from one fraction to the other, and you use that same operation for the missing value. Alright, the last part of this section is a discussion or reminder that fraction bars can also indicate division. So 4 divided by 4, or 4 over 4, you would just write 1. 4 over 1, you would just write 4. Negative 7 over 7 would just be negative 1. Negative 7 over 1 would be negative 7. 15 over 3 would just be 5. And 12 over 3 would be 4. So sometimes those fractions reduce to integers because they actually are just dividing. And so keep that in mind as you work through these. Sometimes the answer is just an integer if it divides nicely. And that is the end of section 4.2, reducing fractions. Hopefully a refresher, hopefully this all makes sense. And we are going to skip for just a minute. The next page of your notes is section 4.5. Section 4.5 are on mixed numbers and estimating, and we're just going to focus on converting mixed numbers and rounding right now. We'll go back to section 4.5 and do the operations later. But right now we're just going to focus on how to convert them back and forth and how to estimate them. So mixed numbers are used to fix improper fractions. And mixed numbers drive me crazy, so we're going to go through this to kind of help you convert from one to the other. Mixed numbers can be very helpful. You see them a lot in recipes. If you need 2 2/3 of a cup of something, and you see mixed numbers there. But really, in algebra, we tend to keep our improper fractions. But let me just show you how to switch back and forth. So if we're going to go from an improper fraction to a mixed number, the first thing you want to do is divide the denominator into the numerator. That tells you the whole part. And then you're going to write the remainder over the original denominator. And that is what we call the part. So a mixed number has a whole number and then a fraction right next to it as the part. So we're going to have a whole number and then a fraction right next to it. So 17 over 5. We're going to think, how many times does 5 go into 17? And the answer would be 3, which makes 15. So 5 times 3 is 15. That gives me 2 as a remainder over 5. So 5 goes into 17 3 times with 2 left over. So there's dividing and there's subtracting involved in this. How many times does 2 go into 5? Well, it goes in twice, which would make 4. That leaves me 1 left over. So the leftover goes over the denominator. We write the whole number bigger and the fraction smaller. Let's try that again. 4 goes into 14 3 times, and that gives me 2 left over. 2 out of 4, hopefully you'll recognize, can be reduced, and it will need to be reduced. So that's going to give you 3 1/2. So that would be what you would enter. So if you get to a remainder, and when you put it over the denominator it can be reduced, go ahead and reduce it. If you want to pause and try the last two, go right ahead. 5 into 33. 5 goes into 33 6 times with 3 left over, so it'll be 6 3/5. Finally, 10 goes into 58 5 times with 8 left over, and that will reduce to 5. These can both divide by 2, so it'll be 4/5. So again, if that remainder over the numerator can be reduced, go ahead and reduce it. And now we're going to go the other way. We're going to write mixed numbers as improper fractions. So to do that, we, instead of divide, we're going to do the opposite. We're going to multiply the denominator by the whole number, and then we're going to add that to the numerator. And we write the result over the original denominator. So we're reversing our steps. Instead of dividing and subtracting, we're now multiplying and adding. So let's do a few of those. You're going to have 3 times 5. So we're going to multiply here, 3 times 5, and then we're going to add 2. 3 times 5 is 15, plus 2 is 17. And we'll put that 17 over the original denominator. So it's just the opposite of that first one. Here we're going to do 4 times 10.